Good day and welcome to the Maths Room. In today's video, we'll be having a look at upper and lower bounds and how they're used in exam questions, such as the ones on the board. Let's get started. Here, we're looking for the upper bound of the area of the rectangle. So what the question is actually asking here is, what was the biggest size that the original before rounding measurements could have been? So 26 and 35 centimeters have been rounded. So we're trying to see what it could have been before the rounding occurred. So let's have a look at the length of the rectangle. They say it's 35 centimeters and it was rounded to the nearest centimeter. So if we put that on a number line, we know that it's going up in centimeters. So the smallest, the lower bound, would have been 34.5. That's the smallest number that it could have been that still would round up to 35 centimeters. 35 according to our rules, 4 would have been the largest number that would still round down. But there's a problem with what we're saying here, because there's also 35.49, which would still also round down to 35 centimeters. And this continues on. So when we're talking about the upper bound, we classify it as 35.5, and using inequalities, it would be greater or equal to 34.5 and less than 35.5. But when we're using it with the upper bound, we will just use it as 35.5. Here are a couple for you to try. What you'll see as you're doing these is that a little bit of a trick to use is always to take whatever degree of accuracy you're working with and halve it. Then to find the lower bound, you'll just take that amount away, and to find the upper bound, you'll add that amount to it. Pause the video now if you want to give these a go. So the first one was to the nearest centimeter. So we're going to take 1 centimeter, divide it by 2, so we get 0.5, and add it and take it away to get the upper and lower bounds. The second was to 1 decimal place. So we're going to take 1 decimal place, so 0.1, and divide it by 2, so we get 0.05. And we're going to add that and take it away. The last one is to 10 meters. So we once again take 10 meters, divide by 2, so we get 5 meters. To get the lower bound, we take it away, and the upper bound, we add it to the original. So now that we know those fundamentals, let's get back to the question. First off, we're going to find the upper and lower bounds of the length and the width. Looking at what the actual question is asking, it's asking for the upper bound of the area of the rectangle. So it's asking for the largest possible value that the original could have been. So in order to do that, because we're multiplying the length and the width, it makes sense that we would need to multiply a large number with a large number in order to result in a large number. So we'll take the upper bound of both the length and the width. Multiplying them together, we can get our final answer, which needs to be squared because we're working with area. Here are 2 for you to try. Pause the video now if you want to have a go. And if this video has helped, consider giving it a like and subscribing for more to come. First up, I always recommend writing down all the lower and upper bounds so that you have them available for when you're thinking through the question. Next, we need to be a little bit careful on this one. Our question is asking us to calculate the upper bound for the slanted length. So the formula as it is needs a little bit of rearranging. So we need to divide both sides by pi r, resulting in a formula that looks like this. The question is then asking us to calculate the upper bound for L. In order to do this with a fraction, I would need the largest number at the top divided by the smallest possible number, which would mean I would want the upper bound for my area, my A, and a lower bound for my radius. Plugging those values in, and we get a result of 9.3583. Starting off the next question, similar way, we're going to write down all the lower and the upper bound values. Now we need to look at what they are asking us. Here, it's a little bit different because they're asking us to find the lower bound of the value y. So we need a small value at the top being divided by the largest possible value. So small value at the top, we would want the lower bound of A, and we're going to divide that by a large number. Now, the denominator is B minus C, so I want the biggest number possible there. So I'm going to take a really big number for B upper bound. I'm going to take away the lower bound of C, which will result in the largest possible value. Plugging these values into my equation and multiplying and dividing, we get 7.5, because remember, they have asked us to give the answer correct to two significant figures. I hope this video has helped. If it has, give it a like and subscribe for more. We'll be releasing videos weekly, and there's lots more to come.